Hey guys, Mr. Wilson here. Today we're looking at simplifying radicals number one notes, numbers only. Okay, at the end of this video, you should be able to simplify radicals containing numbers, and you should be able to simplify the product of radicals. All right, let's start with the problem. It says to solve the equation x squared equals 50, we need to get rid of the exponent to get the variable by itself. Okay, how would we get rid of this exponent? Okay, we need to undo the squared term by using the square root, okay, or radical. This is also called a radical, okay, and this is what we mean when we talk about simplifying radicals. Okay, just like addition undergoes subtraction, just like addition undoes subtraction and division undoes multiplication, taking the square root or taking the root, square root of a squared number undoes the squared term. Okay, so you see that here we have 13 squared, the square root of 13 squared. Square root of a squared number cancels each other out, gives me 13. Square root of a squared number here, 7,148, cancels each other out. Okay, we don't need a calculator to do any of those because they're just inverse operations, just like multiplication is to division and subtraction is to addition. So, to solve the equation above, we would take the square root of both sides. Radical x squared equals radical 50. Okay. On our left side, the square and the square root cancel out. The square root and the squared exponent cancel. No, that's what I said. And we're left with just radical 50. X equals radical 50. Okay, however, radical 50 is not in simplest radical form. Okay, and that's what we'll be asked to write our answer as for most of this chapter. And that's what we're going to learn how to be doing today. Okay, using simplest radical form. Okay, this is what we do. We'll use the properties of radicals to be able to simplify them and write them in a way that would be considered as simplified as possible. Okay, and you might even hear it as the exact answer. Okay, what this says, our first radical, it says radical A, sorry, our first property. What it says, radical A times radical B equals radical AB. Okay, what this says, if I'm multiplying two radical expressions together, I can multiply the two things under the radical to make one radical expression. For instance, if we have radical 12 times radical 3, they're both underneath the radical, and so we could rewrite this as radical 12 times 3, still underneath the radical, which gives us radical 36. And if you remember square root of 36 or radical 36, that's 6. Okay. Okay, the inverse of this property is also true, meaning if we were doing division, we could divide. Like radical A divided by radical B equals, I'll just write it up here. So when we talk about the inverse, if we said radical A divided by radical B, that would equal radical A over B. Okay, just division here. Okay, all right. One method that we can use to simplify radicals is prime factorization. There's another method I can show you, but this is the method I'll be using this year. Prime factorization is basically, we're going to make a multiplication problem out of our numbers in order to see what our simplest radical term is. Okay, so as we look at 50, we're going to try to break it down so we get all the prime numbers. Okay, so as we do this, again, we're just making multiplication problems. 5 times 10 gives us 50. 5 is a prime number, so we can't break it down anymore. That's 5. 10 is not prime. We can break it down. 5 times 2. 5 is prime. 2 is prime. Remember, when we talk about prime numbers, that means the only thing we can do to multiply to get to that number is multiply it and itself, or sorry, itself and 1. Okay, once we get to that, then that's a prime number. Okay, what about 120? Okay, again, just thinking about two numbers that go into 120. 12 and 10. 12 times 10 is 120. Okay, as I break that down, 6 times 2 gives me 12. 2 is prime. 3 times 2 gives me 6. These are all prime numbers. 10, 5, and 2. Okay, so as we write our prime factorization out, we got a 5, we've got a 3, and then we've got 1, 2, 3 2s. Times 2 times 2. You can double check once you multiply these, they should give you 120. Okay. So now it says, how does prime factorization apply to radicals? This is what we need to understand. When we looked at radical 50, we just broke that down to prime factorization. We had radical 5 times 5 times 2. Okay, a radical or a square root is a number that we can multiply itself by to get to a number on the outside. So for instance, when we did 36, radical 36, understand our answer was 6. The reason our answer was 6 because as we broke this down, a couple different ways we can break this down. We can look at it and say, hey, we had a 6 times 6. We had a pair, it went on the outside. But just to drive home the point about our radicalization, if we broke it down even further, 3 and 2, 3 and 2. Okay, we have a pair of 3s. We have a pair of 2s. As we take our square roots, what a square root does is we need 2 factors to be able to take the number to the outside. Okay, we have 2 3s to the outside. We have 2 2s, take it to the outside. And inside of our radical, we have 1 left. Okay, square root of 1 is 1. We typically don't have to write that. I say typically, but we don't have to write that. 3 times 2, 6. That's how we get the square root of 36 is 6. Okay, so let's look here. 36 is a perfect square number. Before I go any further, let's write the perfect squares. So on your notes, guys, write your perfect square numbers here. Okay, remember those are just the numbers that when you multiply a number by itself, it's a perfect square. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5, 35, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. Okay, these are the perfect square terms that you should be familiar with. It will save you time. Okay, just as when we looked at this radical 36, because we recognized that we had 6 times 6, we could have been done there. And if we didn't recognize it, we had to take another step in simplifying it. Okay, so you'll understand that more as we go through. Okay, so we have radical 50. As we broke down our prime factorization, already done, so just going here, we have a pair of 5s. Because we have a pair, it goes out of the radical. When it goes out as a pair, on the outside is written as one thing. Okay, and inside is 2. Okay, again, we already broke down radical 120 on the other side. 5 times 3 times 2 times 2 times 2. Okay, I'm going to do a different color here just so I don't confuse myself when I'm writing. All right, so we have inside of our radical 5 times 3 times 2 times 2 times 2. I'll find my pairs. 5 doesn't have a pair. 3 doesn't have a pair. 2 does. You have a pair of 2s. There's another 2, but it's not in the pair. Okay, you can kind of think of this as a date, right? You got somebody you like or somebody that's like you here. You take them out. Okay, and on a date, you won't be like asking 2 people out at the same time, hopefully. Okay, and so what doesn't have a pair stays inside. 5 times 3 and 2. 5, 3, and 2. 5, 3, and 2 did not have a pair, so it stayed inside. And what we do with those numbers is we just multiply it. If we take more than one pair out, we multiply them. If we keep more than one number inside, we multiply it. So we have 2 radical. 5 times 3 is 15, times 2 is 30. This is our big idea. This is what we're doing. Okay. We can dress that up a little bit and use the factor tree to simplify, just like we did on the bottom of the last page. Okay, our rule for the factor tree is basically multiply, make a multiplication problem, and don't use the number 1. Okay, and keep doing that until you could only use number 1 and circle your prime factors. So as I look at 4 and 48, I'll say, okay, well, 4 times 12 is 48. 4 is 2 times 2, That's a prime number. Those are both prime numbers. 12 is 6 times 2, and 6 is 3 times 2. Okay, so I've broken it down so that I only have prime numbers. This is my prime factorization. I'll write that here. All my terms here, I have a 3, then I have 1, 2, 3, 4 2s. I take my pair out, pair of 2s out, pair of 2s out. So outside of my radical now I have 2 2s, and inside of my radical I have a 3. Okay, 2 times 2, 4. Radical 3. That is radical 48 simplified. Okay. I do not have to choose the combination 4 and 12. At the beginning of this problem, I could have said, hey, 16 times 3 is 48, and done the same thing. Okay. In the next problem, we have radical 30. So as we break this down, we can say, okay, that's 5 times 6. 5 is prime. 6 is 2 times 3. Okay, you'll notice as we look at this, there aren't any pairs. 5 times 3 times 2, no pairs. So simplest radical form for radical 30, we can't take anything on the outside, and everything that's left on the inside we multiply together. That gives us radical 30. Looking at 16, and you should notice, hey, 16 is on our 16 is on our perfect squares list, right? This is how that helps us out some. When we look, we're like, okay, what times what gives us 16? 4 times 4. Okay, we could break this down further, but we're looking for pairs of numbers. We already have a pair here, 4 and 4. Okay, so we have a pair of 4s. We can take that on the outside and get us 4. Square root of 16 is 4. Okay, like I said, if we broke it down further, 2 and 2 and 2 and 2, we get the same thing. 2 times 2 times 2 times 2. We'd have 2 pairs of 2s on the outside. 2 times 2 is 4. Okay, so the combination there doesn't really matter. All right, moving on. Okay. Here it says simplify, or summary. When simplifying radicals, we look for pairs of the same numbers under the radical signs. These can then be simplified, and a number can be brought out from underneath of this radical sign. Anything that is left, or anything that is alone, is left underneath the radical. Okay, and if we leave multiple numbers underneath the radical, we just multiply it. So let's look at some couple tougher problems. And they're tougher because we have some things on the outside, some things on the inside, we're multiplying. Okay, so we have 8 radical 27. Notice there's already an 8 on the outside. So we have to break down 27. So I look at it as 9 times 3. 3 is prime. 3 times 3. Okay, so I had a pair of 3s and a 3 without a pair. So I can write that as 3 radical 3. Remember, we already have an 8 here, so we need to make sure that we write that on the outside. 8 times 3 is 24, radical 3. For number 2, we have radical 5 times radical 8. We can multiply these two and get us radical 40. Because they're both underneath the radical, we can just multiply it. Okay, so now we start making our multiplication problems again. 4 times 10, 2 and 2. 5 and 2. Okay, so we have a pair of 2s that goes on the outside. Then we have a 5 and a 2 that don't have a pair. 5 times 2, 10. Okay, in number 2, we combine radical 5 and radical 8 to make radical 40. And we're allowed to do that since both numbers were inside the radical. We can also combine numbers that are both on the outside of the radical. It's like we did when we had radical 3, or 3 radical 3 times 8. Okay. The only combination we cannot make is a number on the outside of the radical with the number inside. Okay, so I'll say outside by outside, inside by inside. Okay, I'll say that a lot this chapter. Okay, let's do these next few examples here. Okay, so let's look at these different questions. So we have radical 14 times 9. Okay, again, the rule that we'll say a lot is inside by inside, outside by outside. Notice that radical 14 is inside the radical and 9 is outside of the radical. Okay, and so what we'll do, and I'm just going to kind of do a long way for this first one. Radical 14 is actually 1 radical 14, and 9 is kind of 9. Okay, we could call it radical 1. 1 and 2. Never have to do this again, but I want to show you why this works out. Okay, so our rule is inside by inside, outside by outside. The numbers that are on the outside, 1 and 9. 9 times 1 is 9. Inside by inside, radical 14 times radical 1 is radical 14. Okay, anytime you multiply and get a radical, you should check and make sure that you can't simplify it any further, but for 14, you can. So radical 14 times 9 gives us 9 radical 14. Okay, and that's our final simplified answer. Okay, number 4, we have 6 radical 2 times 3 radical 50. Okay, so outside times outside, 6 times 3 is 18. Inside times inside, radical 2 times radical 50 is radical 100. Okay, hopefully you're like, oh, 100, yes, that makes it easy, because we know that 10 times 10 is 100. So radical 100 is actually 10. So we have 18 times 10, I'll do that here, equals 180. So 6 radical 2 times 3 radical 50 is 180. Number 5, we have negative 6 radical 3 times 4 radical 8. Negative 6 times 4, negative 24. Okay, outside times outside. And negative, positive works out. Negative 3. Radical 3 times radical 8 gives us radical 24. Okay, again, we have a radical here. We want to simplify that. As we attempt to do so, we got 6 and 4, 3 and 2, 2 and 2. Okay, all those are prime. Okay, so we have a pair of 2's that we take out. So on the outside, we have negative 24 and the pair of 2's that we took out. And then on the inside, we have the 3 times 2 we couldn't take out. There are no pairs. So we multiply the outsides together. Negative 24 times 2 is negative 48. Multiply the insides together. Radical 3 times radical 2 is radical 6. And then number 6, we have radical 6 times 5 radical 3. Okay, so outside times outside. 5. Inside times inside, radical 18. 5 radical 18, split that up, 9 and 2, 3 and 3. So we have a pair of 3's that goes out. Goes outside now because it's a pair. And a 2 without a pair. So 5 times 3 is 15. Radical 2. Okay. And there you have it. That's simplifying radicals with numbers only. Be good at that, because then we'll add some variables and some other stuff. Okay, see you.